Hi, so in this video I'm going to show you how to model and set up differential equations involving direct and indirect proportion. So we'll begin with example 1. We're told that at time t minutes, the rate of change of temperature of a cup of coffee as it cools is proportional to, I'm going to underline that, is proportional to the temperature theta of the cup of coffee at that time. So what this means is the rate of change of temperature, so d theta, with respect to time dt, is proportional to the temperature theta. But to work out how they're in proportion, we need to use the constant of proportionality. So now we can say that d theta over dt is equal to minus k theta. K is our constant of proportionality, and it is negative because it is cooling. So as time goes on, the temperature gets lower. And we've been asked to create this model here where theta is equal to 80 to the power of minus kt. So to arrange it in this form, we need to do what's called separating the variables. All that means is we have the thetas on one side and the t's on a different side. So I'm going to move this theta to the left-hand side by multiplying both sides by 1 over theta. And I'm going to move this dt to the right-hand side by multiplying both sides by dt. So now we have 1 over theta, d theta, is equal to minus k dt. So now that the variables theta and t are separated, I'm going to take the integral of both sides. This side with respect to d theta and the right side with respect to dt. So when you integrate 1 over theta with respect to theta, we get the natural log of theta plus a constant term. And because negative k is a constant, we can move this outside of our integral sign. And when you integrate 1 with respect to t, you get t. So this becomes minus kt plus a constant. And I can put both of these constants on one side. So we'll just have a bigger constant that represents both of them. So I'll rub this out and move that over there. Okay. If we go back to the information we've been given that theta is equal to 80 degrees when t is equal to 0, show that we have this model. So now I'm going to find a constant c. We know that theta is equal to 80 when t is equal to 0. So we'll learn natural log of 80 will equal to minus k lots of 0 plus c. Negative k times 0 is 0, so therefore c will equal the natural log of 80. And I can substitute this value of c back into our model over here. So we have a natural log of theta is equal to minus kt plus c ln of 80. Now we'll move the natural log of 80 to the left-hand side, and we'll use the division rule of logs to simplify. So we have a natural log of theta over 80 is equal to minus kt. So now we're going to cancel out this natural log by raising e to the power of both sides. And these will cancel. So we have theta over 80 is equal to e to the minus kt. And finally, we'll multiply both sides by 80, so theta is equal to 80e to the minus kt, which is the model we needed to find. Okay, let's move on to part B. Okay, so in part B, we're given that when theta is equal to 50 and t is equal to 4 minutes, we're asked to find the temperature of a cup after 10 minutes. So to work out this part, we need to work out what k is. So this is the next step of our question. We're going to find k. And remember that k is a constant of proportionality. So we'll substitute in that theta is equal to 50 when t is equal to 4. So we have that 50 is equal to 80 e to the minus 4k. We'll divide both sides by 80 and simplify. So 5 over 8 is equal to e to the minus 4k. Now we'll take the natural log of both sides. These will cancel. So a natural log of 5 over 8 will equal minus 4k. And then we'll multiply both sides by negative 1/4. And this will cancel with this. So k will be equal to negative 1/4 times the natural log of 5 over 8. And when we work this out, we get k is equal to 0.1175. So now we're going to substitute this k back into our model. So finally, we're asked to find the temperature of a cup of coffee after 10 minutes. We're going to find theta when t equals 10. So we'll substitute 10 into our model. So theta equals 80 e to the minus 0.1175 times 10. And this gives us that theta is equal to 24.7 minutes. Okay, let's move on to question 2, which is inverse proportion. Okay, so for example 2, we're told that given dy by dx is inversely proportional to x, and that when x equals 6, y equals 8, and dy by dx is 5 over 3, and we've been asked to find an expression for y in terms of x. So we'll start again using our proportion statement that dy by dx is inversely proportional. Now what this means is that as dy by dx increases, x will decrease. And as x gets bigger, dy by dx will get smaller. So we write this as 1 over x. So this is our model for inverse or indirect proportion. Okay, so again, we need a constant of proportionality. So we'll say dy by dx is equal to k times 1 over x. And we can write this simply as a fraction, k over x. So now we need to find k. Well, we know that dy by dx is 5 over 3 and that x equals 6. So we'll substitute x and dy by dx into our formula, into our model. So we've got 5 over 3 dy by dx is equal to k over x, which is 6. We'll multiply both sides by 6. So we've got 6 times 5 over 3 is k. So therefore, k must equal 10. And now we can substitute this 10 back into our model up here. So dy by dx, I'll just block this off so we keep it organized, will be equal to k 10 over x. And now we're going to separate our variables again. So we can move this dx to the right side using a multiply. So we'll have dy will equal 10 over x dx. And now to work out y, we need to integrate both sides. So these will cancel. So now we've got the integral of dy is y, and this is equal, we can move this 10 in front of our integral. So we have 10 times the integral of 1 over x dx. So therefore, y is equal to 10. The integral of 1 over x is ln, the natural log of x, plus the constant. So now we need to find the constant term. We can go back to the information in the question, and we're told that when y is 8, x is 6. So we'll substitute in y and x. So 8 will equal 10 ln x plus c. So therefore, c will equal 8 minus 10 ln 6. Then we'll substitute this value for c back into here. So y is equal to 10 ln x plus 8 minus 10 ln 6. We can factor out this 10, and we'll use the division rule to collect these together. So finally, y is equal to 10 lots of the natural log of x over 6 plus 8. Okay, well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website at mrmathematics.com. There's a link in the description below. Thanks again, and take care.